to that, the word they'll use is range. Okay. Once you've got that written, you can take a 10-minute break. It's about 45 after, so I'll see you guys, I guess, at 55 after. Okay. So this is the second half of 4.2. We have defined range and domain, but I'm going to talk more to you about that at the very end of the lecture. The next thing I want to discuss with you is something called functional notation. You guys have learned ways of representing things in here so far, like interval notation, set notation. Here's another notation thing. The idea is when we're working with these functions that we've defined, you can represent substituting in values of your variable using some really shorthand notation. F of x is what I'm talking about. See how you see f and you have an x in parentheses? Verbally that reads the function of variable x. So function f of variable x. Somebody help put that into kind of normal words for me. What am I trying to say there with that symbolism? What's my variable going to be? The f or the x? Which one's going to be the input in my function? It kind of makes sense with me. I haven't shown you very much yet, but intuitively you're probably thinking if I'm saying function of, well, the of part, that's what you're going to plug into it, right? And we know that by substituting, generally you would put the x or the number you're substituting in into the parentheses. So it really is f of x, where x is your input. That's what functional notation does. And notice for me, guys, even though I'm using f, I could have used anything. If I put y of x, that's the same thing. Same idea. It would mean function y of x. Now, the reason you'll see f of x is because f for function, who cares? It's the same thing as using a y, or a g, or an h, or a q, who cares? It's whatever the person writing the problem. You guys remember when you were doing the word problems, sometimes you might have favorite letters to use. They can change your letters on you all day long. The two most popular ones are f of x and y of x. Now, I'm going to step back for a moment and remind you that you have seen some functions, some basic stuff. For example, if I gave you y equals 2 times any x I've got plus 1. At this point, I could ask you lots of things. I could ask you, given some certain x values, to please graph this for me. And you should be able to plug in those x's and get out some y's and draw me a graph, right? Everybody's on par with that? I could ask you, is this a function? Well, you can look at those values you just made up to see if x is repeated. Or if you made a table to see if your one button leads to two things. Those are both options. Or you could look at the graph you drew and use the vertical line test. So all of these things work until here. But this is a function. I'll go ahead and tell you just to save you time. Here's a function. Also called an equation because it has an equal sign in, but a specific type of equation called function. Where for this input x, I'm going to have unique y's. Let's see. I could have you find the value for y. We kind of just said that. Let's do an example. I'm going to say example. If x is equal to 4, can you find what y is equal to? What do you do here? What's this telling you to do? Yeah, plug in 4. So y is equal to 2. Where I have the x, I'm going to substitute in a 4 plus 1. And what's y equal to? let's see, 2 times 4, 8 plus 1, 9. I agree with you, Misha. So in other words, I get if I wanted to write ordered pair even, I get 4, 9, right? That's fine and dandy. Look how many words I had to write to explain to you guys what to do. In math, a lot of times we try to abbreviate things with symbols. Let me show you the equivalent question. I could have said, example. I'll use y just for kicks. Or, oh yeah, sure, well, who cares? Y of x. Y of 4 equals what? And again, guys, F is more popular. I'm wanting you to be comfortable seeing different letters. Tell me what this means. You've just been a little bit introduced to functional notation, haven't you? You know that in general, for functional notation, you would have a Y or an F or whatever letter. Inside those parentheses, you have an X, right? Okay, so Y of X. What have I changed about my representation right here? What did I substitute in? Oh, so this meaning here, this original problem we have, that's this one, is a function y where x is my input variable, right? So what I've represented here is, for my function y, now for your input, put in a 4. Replace your x with a 4. Okay. That's not so hard, is it? It means the exact same thing I put in words on the left of the screen. I've replaced my input, my x, with the number 4. So y of 4 is equal to 2 times 4 plus 1. And this is when it becomes especially useful. In this problem on the left, I stopped with y equals 9. And if I hadn't been organized and gone ahead and said, oh, yeah, so when x is 4, comma, y is 9, if I had not been organized and given you that ordered set, or that ordered pair, sorry, you might not have even known how I got y equals 9. Unless you went back and read the paragraph I just wrote, substituted in x equals 4 for y, you know, to find y. Versus this other one on the right, check it out. In one statement, you know everything that has just happened in this problem. You have a lot more control right now. You know when you read it, there's some function y, and what went into it is input. And what came out from output. Good. You know more from that final statement. Math people like that. We like for you to be able to look at one step and know kind of what's just happened. Not just see random y values floating around the page. That's why functional notation serves us so well. Now, of course, I'm kind of spoiling you with using y's everywhere. I told you you can have f of x, right? But it would mean the same thing. Let's find an example where they use f of x. How about, I'll use x squared, our favorite function we just learned about. F of x is equal to x squared. Just for the record, that's the same as y equals x squared. Right? We know it means the same thing. In both cases, we have some input we're calling x, and our output we're either going to call f of x or y. You guys okay? F of x says my function where x is the variable. Y, that's the same thing. Here's my function. I can call it y if I want. I can call my output y. But either way, x squared is on the other side. X is my variable that's being used. So I could say from this, and what's your answer? F of 2 is equal to what? What am I doing here? What's my process? I'm plugging 2 in for what? X. Yeah, that's what's going on here. I have an x. I replace it with a 2. So I'm going to have 2 squared equals what? 4. Okay, so f of 2. When I have an input of 2, I get an output of 4. Even though it does read pretty, I mean, it reads prettier than the stuff we've done back in the day when we did substitution. This right here reads a lot more directly. Even though it reads pretty, you have to be really careful with it. That does not mean some letter F times 2, does it? So we have to be careful with the notation. We have to know that it's saying, we're not multiplying stuff on the left. That's the same as me saying y equals 4 when you put a 2 in for x. That's the same meaning. So be really careful in your homework not to think you got multiplication happening. Understand, this doesn't mean times. This means a function of this variable x. No multiplying here. It's just symbolizing a y. It's symbolizing some equation you're dealing with, some function. Same thing in the answer. No multiplication. This means a function of, or a function when you put in 2 is equal to 4. You can put anything in there, by the way. You guys have played with that before. Let's look at another example. Because like I said, the number one way they're going to try to play with your brain is by changing between f and y and all that stuff. See, look at the example I'm talking about is y of x. Versus here I've got f of x. Who cares? I could say Bob of x. Who cares? What we're calling